Okay, today we are identifying types of reactions. So here we have a list of a whole bunch of different chemical equations representing different types of reactions. And here are our 5 different types of reactions: synthesis, decomposition, single replacement, double replacement, and combustion. This is just something that I've taken from your notes just to give us a nice simple reference that we can use to figure out what type of reaction is taking place here. And I've created these patterns using different variables to represent particles. And those particles can be elements, those particles can be compounds. Down here in combustion, we see that we have specific elements that will always be in a combustion reaction. We'll always have carbon and hydrogen reacting, a compound containing carbon and hydrogen reacting with oxygen. It'll always produce carbon dioxide and water. All these other ones, A's, B's, C's, D's, those all just represent different particles. So you can think of them as a variable. What we're looking for to figure out what type of reaction it is a pattern. And it's these patterns that we really need to be able to key in on to figure out what type of reaction is taking place. So if I look at number 1 here, I have zinc and sulfur coming together to make zinc sulfide. So I have an element plus an element producing a compound. So when I look over here, element and an element making a compound. So that is a synthesis reaction. Number 2 is a little bit tricky. I have NH4OH producing NH3 and H2O. But if I look here, I'm starting out with just one compound. There's only one thing over here that just starts with one compound, and that's a decomposition reaction. And as I can see, it's going to break apart into 2 different things. In this case, A and B are different compounds, where they are typically going to be 2 different elements, one compound breaking into 2 elements. But as we've seen in number 2, this is a decomposition reaction breaking into 2 different compounds. If I move down to number 6, I have a compound and a compound reacting to form a different compound, or 2 different compounds. And if I look closely, I can see that the sodium and the iron have just switched places. Now the sodium is with the chlorine and the iron is with the hydroxide. So that is a double replacement reaction. That's exactly what I see happening here. The A and the C have just switched places. Now A is with D, C is with B. Down here, number 8, I have an element and a compound reacting to form a compound and an element. And the element that's by itself, the element that's by itself has replaced one of the elements that is in the compound. Here, the zinc has replaced the copper. Now the zinc is in the compound. That's the exact same thing I see happening over here. Element, compound. The element that's by itself replaces the element in the compound. So that is a single replacement reaction. And lastly, number 13, here I have C6H14 reacting with oxygen to produce carbon dioxide and water. Hydrocarbon reacting with oxygen to produce carbon dioxide and water. So that is a combustion reaction. It's extremely important that you move down here to the bottom half. You will notice 18 through however many are on this worksheet, there is no products. It is just reactants. And sometimes that can be a bit confusing. But if we look at our patterns without the products, you'll know that each one of those patterns for just the reactants is different. So if I can pick out the type of reaction when I look at the entire equation, I should still be able to pick out the type of reaction just looking at the reactants. And that's extremely important moving forward, because the next thing will be to actually fill in the products, which we call predicting products. But the first step of that is being able to identify what type of reaction it is.